Hello everyone and welcome to our CS125 final project presentation. My name is David Cook and I worked with my partner Matthew Murphy to create an Android application that utilizes the Microsoft Translate API. What inspired this idea to use such an API for our final project was the reminiscing of myself and Matt on the days of childhood when we would take an English sentence and put it through the Google Translate website several times through many different languages that we could never comprehend and see what the English output was. And of course, we couldn't help but laugh every time. We decided to make an app that actually does all that for you in the background. All that's necessary is for you to enter an English phrase, and it will go through as many random languages as you so choose between 1 and 10, and it will output an English sentence based on what the Microsoft API has translated it to. So, let's get started. Here we are at the main activity, and you see we have a translate part, and the output will soon appear in this area once you have inputted something and pressed update. And we also have a number of translations, which is capped at 10. This is because the number of translations increases the runtime of this app because it must send the sentence you have inputted X amount of times to the Microsoft Translate API, which takes time. So to save the user a headache and a half, we have capped it at 10, and if you try to enter more than 10, we will automatically just translate it at a capped 10 times. So here is going to be my first sentence to translate. This is not in the right place. Oops. This is in the right place. Perfect. Let's do this 5 times and we'll press update. And it will slowly load my outputted sentence by calling the Microsoft API 5 times with 5 different random languages based on this inputted sentence. This is the place to stop. Not exactly what I was looking for, but a pretty darn good job by the Microsoft Translate API. As you can see down here, we have a 33.33% match between this sentence and the inputted sentence. This is based off of an algorithm that Matt and I created that utilizes character arrays to walk both of these inputs and outputs simultaneously, comparing the characters that line up in those indices. Every time the characters match up in the right place, we add 1 to a counter, and we take that counter and divide it by the total number of characters in the original sentence, multiply it by 100, and you get the percentage seen below. We're going to take that and we're going to graph it in the grapher, which shows up a nice colorful bar graph. Let's go to another sentence over here to get some more data. I really need to eat dinner. Perfect. Let's do this for just 3 times, save a little time here, by calling the Microsoft API 2 less times than before, and we'll see what it outputs this time. I really need to eat. That's pretty close to exactly what we wanted, and down here we have a much greater percent match. We'll add that to the graph as well. Look at that. Nice and beautiful. Very nice. Sometimes, if we add a very long sentence that has a lot of English-specific words, the Microsoft Translate API will not return the best sentence. So one of the issues we've come across in this project is dealing with the Microsoft Translate API because it takes such an interesting turn after certain languages have been met. Let's see if we can get one. This might become weird. I really hope it does. We'll translate this 3 times, and we'll see what it outputs. Get weird, and I want to. It's true. I sure hope that's not true. But as you can see, it has a significantly less number of match down here. And we'll add that to our graphing data as well, just so you can see. Well, there we go. That is our final project for CS125. I hope you enjoyed it. And thank you. Have a good night.